The cosmos holds more secrets than we have yet uncovered. Today we will explore 30 new discoveries in space that could change everything you thought you knew about the universe. By the end of this journey, you will understand how our fundamental place in reality is being rewritten. We will investigate a mysterious object from another star and a gas on Venus that hints at life. What single discovery do you believe could reshape humanity's future? A strange object from the depths of interstellar space was spotted tumbling past our sun in 2017. Astronomers named it Oumuamua, a Hawaiian word for scout, and it was the first visitor from another star system ever observed. Its arrival was a complete surprise, a rock or perhaps an iceberg from a distant cosmic shore. But its shape was the first puzzle, an elongated, cigar-like form unlike any typical asteroid or comet in our own system. Then came the real mystery. As Oumuamua sped away from the sun, it did something inexplicable. It accelerated as if pushed by an unseen force. Comets do this when their icy surfaces heat up and vent gas, acting like a natural rocket engine. Yet Oumuamua showed no visible coma, no tail of gas and dust that telescopes could detect. This strange acceleration sparked a fierce debate that continues to this day. Was it a comet made of exotic ice that left no typical trail? Was it a porous, dusty aggregate, a cosmic dust bunny shaking off material we could not see? Or, as a few scientists have cautiously proposed, could its movement be explained by something more profound, like a light sail, a piece of natural or even artificial technology using sunlight for propulsion? While that last idea is highly speculative, it forces us to confront a fundamental question. Are we alone? And if not, what might the artifacts of other civilizations look like? Oumuamua did not answer this, but it opened the door. It proved that interstellar objects are passing through our celestial neighborhood, and each one is a messenger carrying secrets from faraway stars. The search for life took a breathtaking turn from that lonely interstellar rock to our closest planetary neighbor. High in the toxic atmosphere of Venus, astronomers found a ghostly fingerprint, a gas that simply should not be there. They detected phosphine, a molecule where one phosphorus atom bonds with 3 hydrogen atoms. On Earth, this gas is notoriously difficult to create through normal geological or atmospheric chemistry. It is primarily made by anaerobic microbes, tiny life forms that thrive in environments without oxygen, like swamps and even our own guts. Finding a significant amount of phosphine in a planet's atmosphere is considered a potential biosignature, a tantalizing hint that life might be the factory. The discovery was shocking because Venus is a hellscape. Its surface is hot enough to melt lead, crushed under an immense pressure 90 times greater than Earth's, and shrouded in clouds of sulfuric acid. Yet, up in a temperate layer of those very clouds, about 30 to 40 miles high, the conditions are surprisingly Earth-like. The temperature and pressure there are almost comfortable. It is in this narrow, habitable band of a hostile world that the phosphine signal appeared. The scientific community erupted in a firestorm of controversy. Could there be a previously unknown chemical process, some exotic Venusian geology, creating this gas without any need for biology? Teams scrambled to reanalyze the data, searching for an error or an alternative explanation. So far, no abiotic process found can account for the amount of phosphine observed. This single finding has completely revitalized the scientific interest in our sister planet. Space agencies are now drawing up plans for new missions to Venus, probes that will dive into those acidic clouds to sample them directly, hunting for the definitive answer to a question we never thought we would ask. Could tiny, floating life forms be making a home in the skies of Venus? While we search for life in the clouds of Venus, a much closer discovery is reshaping our own future in space. Scientists have confirmed the presence of water on the sunlit surface of the Moon. This is not hidden in the permanent shadows of deep craters at the poles, but out in the open where sunlight beams down. For decades, we believed the lunar surface was bone dry, that any water ice could only survive in the coldest, darkest traps. This new finding shatters that old assumption. The discovery was made by a remarkable flying observatory called SOFIA, a large Boeing aircraft with a massive telescope built into its side, flying high in the Earth's atmosphere above most of the water vapor that distorts observations. SOFI appeared at the Moon and detected the specific chemical fingerprint of water molecules. It found them in one of the largest craters visible from Earth, a sun-drenched region where temperatures are scorching. The water is not in the form of pools or ice blocks, but is likely trapped within glass beads created by the intense heat of micrometeorite impacts or tucked between grains of lunar soil. This changes everything for human expansion into the solar system. Water is the oil of space exploration. It is not just for drinking, but when split into its components, hydrogen and oxygen, it becomes breathable air and powerful rocket fuel. The prospect of harvesting this water directly from the lunar surface means we could potentially establish permanent bases that are far more self-sufficient. The Moon could transform from a destination into a cosmic gas station, a vital stepping stone from which to launch missions deeper into space to Mars and beyond. This accessible water makes the dream of a sustained human presence on the Moon, and all the possibilities that flow from it suddenly feel much more like an impending reality. Just as we ponder the secrets of our own solar system, a signal arrives from the void with a clockwork precision that defies explanation. Billions of light years away in a distant galaxy, astronomers detected a fast radio burst that repeats not randomly, but in a steady, predictable rhythm. For 4 days, it would unleash a millisecond blast of immense energy, then fall completely silent for 12 days, only to start the cycle again. This 16-day pattern was the first of its kind ever found, a cosmic heartbeat pulsing across unimaginable distances. A fast radio burst is one of the universe's most powerful and mysterious events, a flash of radio waves that, in a mere thousandth of a second, can release more energy than our Sun does in 80 years. Most appear as single, cataclysmic events, likely the final death cries of stars being torn apart. But a repeating burst, and one with such a clear schedule, points to something entirely different, a source that is not destroyed in the process. What natural cosmic engine could possibly power such a phenomenon? The leading suspect is a magnetar, a type of neutron star with a magnetic field so intensely powerful it could strip the information from every credit card on Earth from halfway across the galaxy. One theory suggests a magnetar wobbling through its orbit, its powerful beams sweeping across space like a lighthouse, periodically pointing toward Earth. Another idea involves an object like a neutron star moving through a thick cloud of gas and dust, flaring up each time it plows through the densest material. Yet, the sheer power and the eerie regularity inevitably lead to more speculative, thrilling possibilities. Could this be evidence of an advanced civilization, perhaps using unimaginably powerful propulsion systems or communication devices that we are only just able to glimpse? While extraordinary claims require extraordinary evidence, the very existence of these patterned signals forces us to broaden our imagination. Decoding the source of these bursts is not just about identifying a strange object, it is about probing the most extreme and energetic physics in the cosmos. Each flash is a message written in the language of pure energy, telling us about the fundamental forces that shape reality itself. The steady rhythm of those distant radio bursts hints at cosmic order, but a far closer discovery offers a tangible target for our deepest hopes. Just 4.2 light-years away, our very nearest stellar neighbor hosts a world that could mirror our own. Orbiting Proxima Centauri, a small, faint red dwarf star, is Proxima Centauri b, an exoplanet almost exactly the same size as Earth. More crucially, it orbits within its star's habitable zone, that narrow, life-friendly band where temperatures are just right for liquid water to potentially exist on the surface. Imagine a planet so close that its parent star appears not as a disk, but as a permanent, deep red orb in its sky, a world locked in a gravitational embrace so tight that a full year passes in just 11 Earth days. This proximity is both its promise and its peril. Red dwarf stars like Proxima Centauri are notoriously turbulent, frequently erupting with powerful stellar flares that could bathe the planet in deadly levels of radiation. This raises a fundamental question: could any atmosphere or any life survive in such an environment? The answer depends on whether Proxima b possesses a strong magnetic field to deflect those stellar attacks or a thick atmosphere to shield its surface. Without these defenses, the planet could be a barren, irradiated rock. Yet, if it holds onto its protective layers, vast oceans could pool on its surface, perhaps huddled on the hemisphere, permanently facing the star or circulating heat around the globe. This single world, practically on our cosmic doorstep, transforms interstellar travel from a far-off dream into a conceivable, albeit monumental, engineering challenge. It is the prime destination for projects like Breakthrough Starshot, which envisions sending tiny, laser-propelled probes to this system within a human lifetime. Finding an Earth-sized planet in the habitable zone of the closest star feels like a message from the universe, a direct invitation to look beyond our solar system and wonder if, just next door, another world is waiting. The search for life on distant worlds forces us to look closer to home, to a star that suddenly and dramatically changed. Betelgeuse, the brilliant red shoulder of the Orion constellation, began to fade. This was not a slow, gradual dimming, but a precipitous drop in brightness, a stellar vanishing act that captivated the world. Over a few short months, the star lost more than 2/3 of its normal luminosity, becoming a faint echo of its former self. For the first time in recorded history, this celestial landmark was visibly dimmed to the naked eye. The immediate, breathtaking speculation was that we were witnessing the final act. Betelgeuse is a red supergiant, a star in its death throes, and astronomers know it will one day explode as a supernova. The great dimming seemed to signal that the end was near, that we were about to see a star die in a blaze of glory visible even in our daytime sky. The universe, however, had a different, more subtle story to tell. When astronomers turned the full power of modern observatories toward the star, they found the true culprit. Betelgeuse had not faltered at its core. Instead, it had coughed. The star, in one of its regular cycles of pulsation, ejected a massive plume of superheated gas. As this material traveled away from the star, it cooled and condensed into an enormous cloud of dark, obscuring dust, a cosmic veil that drifted between Betelgeuse and our telescopes. We were not seeing a star about to die. We were seeing a star literally creating its own funeral shroud. This event was a masterclass in stellar behavior. It revealed the dynamic and messy process of how massive stars like Betelgeuse lose mass, seeding the cosmos with the heavy elements that will one day form new planets and potentially new life. The Great Dimming was a reminder that the universe is a place of constant, dramatic change, and that sometimes the most profound discoveries come from watching the shadows gather around a fading giant. Our galaxy holds its own colossal secret, one that stretches far above and below the starry plane we see in our night sky. From the heart of the Milky Way, two enormous bubbles of energy extend outward, each a towering structure of gamma rays that spans 25,000 light-years from end to end. Imagine a cosmic hourglass, its center at our galactic core, with lobes so vast they encompass half the visible sky. We call these the Fermi bubbles, and for years they were completely invisible to us, hidden in plain sight until space telescopes designed to see the universe's most energetic light finally revealed their faint, gigantic outline. Their origin is a puzzle written in gamma rays. One leading theory points directly to the sleeping giant at our galaxy's center, the supermassive black hole known as Sagittarius A star. Astronomers propose that millions of years ago, this black hole awoke from its slumber in a violent feeding frenzy. As it devoured an enormous clump of gas or even an entire star, it did not just consume the material, it belched a significant fraction of it back out, shooting twin jets of superheated plasma and radiation directly upward and downward from the galactic disk. These jets, traveling at nearly the speed of light, would have inflated these massive cavities, pumping them full of energetic particles that still glow with gamma radiation today. An alternative theory suggests a different kind of eruption, not from the black hole, but from a frenzy of star formation. The galactic center is a crowded, tumultuous place, and a period could have occurred where thousands of stars were born in quick succession. The most massive of these stars would have lived fast and died young, exploding as supernova in a coordinated chain reaction. This starburst could have blown a powerful galactic wind, a shockwave of such force that it carved out the very bubbles we see. These structures are not ancient, static relics. They are a dynamic and ongoing event. The edges of the Fermi bubbles are remarkably sharp, suggesting they are the result of a relatively recent and short-lived cataclysm, one that occurred perhaps just a few million years ago. Their presence forces us to rewrite the history of our own Milky Way, revealing it not as a quiet, stable spiral, but as a galaxy with a violent and active past. This discovery proves that even the most massive structures can remain hidden until we learn how to look, and it begs the question of what other invisible giants are shaping the cosmos around us. Far beyond our solar system, a world unlike any other orbits a cool, dim star. Designated K218b, this planet is a super-Earth, a class of worlds larger than our own but smaller than the ice giants Neptune and Uranus. What sets this distant globe apart is not just its size, but what telescopes have glimpsed in its skies. Data from the Hubble Space Telescope and other observatories suggest the planet possesses a significant atmosphere, and within that atmospheric veil, the chemical signature of water vapor appears strong. This is a monumental detection. Studying the atmosphere of an exoplanet is one of the most difficult tricks in modern astronomy. Scientists wait for the planet to transit or pass directly in front of its host star from our point of view. As this happens, a tiny fraction of the star's light filters through the planet's thin, outer atmosphere. Different gases in that atmosphere absorb specific colors of this starlight, leaving behind a faint barcode of chemical fingerprints. By reading this complex code, astronomers can decipher what the alien air is made of. On K218b, the data paints a compelling picture. This super-Earth likely belongs to a proposed new category of planets called Hycean worlds. Imagine a planet with a global, scalding hot ocean, completely covered in water beneath a thick, hydrogen-rich atmosphere. These are not terrestrial landscapes with familiar continents, but vast, waterlogged spheres where the boundary between ocean and sky might be blurred into a superheated, steamy haze. The conditions on a Hycean world would be extreme, far too hot for life as we know it on the surface. Yet within its deep, dark ocean, shielded by miles of water and that immense atmospheric pressure, could pockets of habitability exist. Just as life thrives near hydrothermal vents at the bottom of Earth's oceans, entire ecosystems might survive in the abyssal depths of a Hycean world, completely independent of sunlight. The discovery of K218b and its water-rich atmosphere fundamentally expands the zone where we might find habitable environments. We are no longer looking only for pale blue dots, for Earth twins with rocky surfaces and temperate climates. We are now learning to search for water worlds, for planets where life, if it exists, would be entirely aquatic, hidden beneath a crushing, gaseous shroud. This single finding opens up a vast new frontier in the hunt for life, reminding us that the universe's creativity in planet building far exceeds our own. That search for life in alien oceans brings us face to face with the ultimate cosmic void. We have now seen the unseeable. In April 2019, a global team of astronomers unveiled humanity's first direct image of a black hole. This was not an artist's impression or a simulation, but a real picture of the fiery maelstrom surrounding the supermassive black hole at the heart of the galaxy Messier 87, a colossus weighing in at 6.5 billion times the mass of our Sun. The image showed exactly what Einstein's theory of general relativity predicted a century ago: a dark central shadow, the event horizon, encircled by a brilliant, lopsided ring of light. This shadow is the black hole's silhouette, cast against the incandescent glow of matter being ripped apart at nearly the speed of light just before it plunges into oblivion. The ring is brighter on one side because the material is moving so fast. The side spinning toward us appears brighter due to a phenomenon called Doppler boosting, a relativistic effect that makes approaching light sources appear more intense. Capturing this image was a feat of almost unimaginable scale. The Event Horizon Telescope was not a single instrument, but a virtual telescope the size of the entire Earth. By synchronizing 8 radio observatories across the globe, from the high deserts of Chile to the volcanic peaks of Hawaii and the frigid landscape of the South Pole, the collaboration created an interferometer with a resolution sharp enough to read a newspaper in New York City from a sidewalk cafe in Paris. They had to collect petabytes of data, so much information that it was easier to fly physical hard drives to central processing facilities than to send it over the internet. For years, teams of scientists worked to calibrate, analyze, and piece together this cosmic jigsaw puzzle. The result was a perfect match for the predictions of general relativity under the most extreme gravitational conditions imaginable. This single, hazy orange ring confirmed that the bizarre, warped spacetime around these monsters is real. It proved that black holes, once purely theoretical mathematical curiosities, are not just out there, they look exactly as our most brilliant minds foretold. This image is more than a photograph. It is a direct window into the heart of darkness, a testament to human collaboration, and a new tool for probing the fundamental laws that govern the universe. Our view of a star-centered cosmos is fundamentally incomplete. We have long imagined planets as orderly worlds orbiting a parent sun, but a staggering new census reveals a hidden population of drifters. These are rogue planets, dark, frozen worlds that have been ejected from their stellar systems to wander the emptiness of interstellar space. The most incredible finding is not just that they exist, but that they may vastly outnumber the stars in our galaxy. For every single star you see in the night sky, there could be thousands, even millions of these lonely nomads. They do not reflect any light, they emit almost no heat, making them nearly impossible to see with conventional telescopes. So how do we find something that is essentially invisible? The answer lies in a cosmic quirk of gravity called microlensing. Imagine a rogue planet drifting silently between a distant star and our telescopes here on Earth. The planet's gravity, though weak, acts as a tiny lens, bending and focusing the light from that background star for a brief moment. From our perspective, the star behind it will appear to momentarily brighten, then fade back to normal as the planet moves on. This flash in the dark is the only signature of the rogue's passage. By scanning the sky for these fleeting events, astronomers have calculated the sheer abundance of these dark worlds. Their existence rewrites the story of planetary formation. We used to think of solar systems as stable, orderly places where planets form and remain in peaceful orbits. The prevalence of rogue planets tells a far more violent and chaotic tale. It suggests that in the early, turbulent days of a star system, gravitational interactions between young, massive planets can easily fling smaller siblings out into the deep cold, a cosmic game of pinball with worlds as the balls. This raises a profound and haunting question. Could any of these exiled worlds harbor life? It seems impossible on the surface, a planet adrift in the perpetual night, far from the warmth of any star. Yet, if a rogue planet were large enough, with a thick, insulating atmosphere of hydrogen or a subsurface ocean kept liquid by tidal forces or radioactive heat from its core, it could potentially trap enough internal warmth to create a livable environment. Deep beneath a global shell of ice in a dark, pressurized sea, microbial life might persist for billions of years, completely isolated and unaware of the universe outside. These wanderers represent an entirely new class of habitat, one that operates independently of starlight. They are a testament to the resilience of planetary systems and a reminder that life, if it exists, may be hiding in the most desolate and unexpected corners of the galaxy, forever drifting in the silent dark. Even as we contemplate life adrift in the interstellar dark, our robotic geologists are making stunning finds right next door. On the dusty surface of Mars, the Curiosity and Perseverance rovers have been scraping at rocks and sniffing the thin air, uncovering a treasure trove of organic molecules. These are not signs of life itself, but something almost as profound, the complex carbon-based building blocks that life requires to get started. Finding them on Mars shatters an old belief that the planet's surface is utterly barren of the ingredients for biology. The rovers did not find simple carbon chains, but a diverse suite of complex compounds, including thiophenes and aromatic hydrocarbons, locked within ancient mudstone that formed at the bottom of a long-vanished lake. These molecules are the durable remnants of much larger organic structures that existed billions of years ago. The immediate question is, where did they come from? They could be the fossilized leftovers of ancient Martian microbes, a tantalizing possibility. But they could also have a non-biological origin, delivered by ancient asteroid impacts or forged through chemical reactions between water and rock. The very persistence of these compounds is a clue in itself. Mars is bombarded by intense solar and cosmic radiation, which breaks down organic molecules over time. The fact that these building blocks have survived for 3 billion years protected within clay-rich rocks suggests they were once far more abundant. It paints a picture of a young Mars that was strikingly similar to the early Earth, a wet world with lakes, rivers, and all the necessary chemistry for life to potentially emerge. This discovery transforms the red planet from a simple desert into a world with a rich and complex chemical history. It tells us that the recipe for life was written on Mars just as it was on Earth. The great unknown is whether anyone or anything was ever there to read it. Just as we learn the chemical language of Mars, a new kind of cosmic scream shatters the silence. In June 2018, telescopes caught a flash in a distant galaxy so bizarre it was immediately nicknamed the Cow. This was not a typical supernova. It appeared in hours, not days, and shone with a ferocious brightness up to 100 times more intense than a normal stellar explosion. For a few brief days, it outshone its entire host galaxy, a flashbulb popping in the cosmos. Then, almost as quickly as it arrived, it faded away. This speed was the first clue that the Cow was something entirely new. A normal supernova involves the collapse and violent rebound of a massive star's core, a process that creates an expanding shell of debris that glows brightly for months. The Cow did not follow this script. Its light curve, the graph of its brightness over time, was a steep, sudden spike and a rapid decline, more like the brief, intense flare of a short-lived event than the long, drawn-out death of a star. The light it emitted was also strangely blue and incredibly hot, suggesting a powerful, compact energy source was at work, something far smaller and more energetic than a spreading cloud of supernova debris. The leading theory is that we witnessed the birth of a new compact object in real time. Astronomers believe the Cow may have been the moment a massive star collapsed not into a full-blown supernova, but directly into a black hole or a highly magnetized neutron star. In this scenario, the star's core implodes and a nascent black hole begins to form at its center. As the outer layers of the star rain down onto this newborn singularity, they form a swirling, superheated accretion disk. Some of that infalling material is then funneled out at nearly the speed of light in powerful jets that punch straight through the star's outer envelope. We were not seeing the star explode outward, but rather looking directly down the barrel of a relativistic jet, a cosmic blowtorch that blasted the star apart from the inside out. This direct line of sight to the engine room of a stellar collapse is what made the cow so brilliant and so brief. It was a fleeting glimpse of a black hole's violent birth cry, an event that rewrites the final chapter for the most massive stars and proves that the universe has more ways to destroy a sun than we ever imagined. Our own solar system may be nestled inside a structure of unimaginable scale. A new theory, built upon decades of radio astronomy data, suggests we are living within a colossal magnetic tunnel. This vast filamentary structure would envelop our entire heliosphere, the protective bubble of particles blown out by the solar wind. If true, it means every planet, every comet, and our own Earth are all traveling through a tube of intertwined magnetic fields that stretches for over 1,000 light years. The evidence for this tunnel comes from connecting two of the sky's most prominent, yet seemingly separate radio features. For years, astronomers have observed two gigantic formations, the North Polar Spur and the Fan region. One is a massive ridge of bright radio emission, the other a strange, haze-like patch that polarizes radio waves. They appear in opposite parts of the sky and were long thought to be unrelated structures. But what if they are not separate at all? The groundbreaking idea is that we are simply seeing the two closest walls of a single, tunnel-like formation, with our solar system positioned almost perfectly in the middle. It is as if we are standing in a long, curving hallway and seeing the glowing walls to our left and right, not realizing they are connected around us in a continuous tube. This magnetic tunnel would not be a solid object, but a braided network of filaments like the intertwined strands of a rope made of charged particles and magnetic energy. These filaments would be the local manifestation of a much larger galactic structure, a remnant of ancient supernova explosions or powerful stellar winds that sculpted the interstellar medium around us. This discovery fundamentally reshapes our understanding of our local cosmic neighborhood. We are not merely drifting through an empty, uniform void. We are navigating an intricate and dynamic magnetic ecosystem. This tunnel would influence how cosmic rays travel through our part of the galaxy and how local star formation proceeds. It redefines our place in the cosmos, not as isolated travelers, but as inhabitants of a grand, invisible architecture whose contours we are only just beginning to trace. That solitary signal from the void remains one of history's greatest cosmic riddles. It was the summer of 1977, and a radio telescope at Ohio State University was scanning the sky, listening to the faint hiss of the cosmos. Suddenly, a needle on the printout chart leaped. For 72 seconds, a powerful, focused beam of radio waves slammed into the antenna, a signal so strong that the astronomer who discovered the data, Jerry Amon, simply circled it in red pen and wrote one word in the margin: "Wow." Then it vanished. The wow signal was everything scientists were looking for. It was a narrowband signal, meaning it was concentrated on one specific frequency, just as you would expect from an intentional transmitter. It was the exact frequency of the hydrogen line, a natural radio wave emitted by hydrogen atoms, a logical choice for any civilization wanting to announce its presence on a universal channel. Yet after that one brilliant burst, it never repeated. Decades of follow-up observations of that same patch of sky in the constellation Sagittarius have found only silence. New analyses have only deepened the mystery. One recent theory suggests the signal could have been amplified by a gravitational lens, a chance alignment where a passing object like a comet or asteroid bent and focused a much weaker, natural signal from a distant source, creating a temporary cosmic mirage. Others have meticulously ruled out every conceivable human origin, from a secret military test to a passing satellite. The signal came from a region of space with no known stars or planetary systems at the time, a seeming emptiness. Its transient nature is its most defining and frustrating characteristic. Was it a one-time beacon, a cosmic hello that we heard only by chance? Did we intercept a powerful burst of communication between two interstellar spacecraft, a message never meant for us? Or was it, as some still hope, a deliberate signal from an intelligence that was listening for a reply we never sent? The WOW signal endures not because it provided an answer, but because it perfectly framed the question. In a universe of natural, chaotic noise, it was a moment of pure, artificial-seeming order, a single, perfect note played in the dark. It stands as a monument to our own yearning, a reminder that the most profound discovery might be a whisper from the dark that we heard once and may never hear again. That lonely interstellar rock was not the first visitor after all. Years before Oumuamua's arrival, our planet was already struck by a messenger from the stars. In 2014, a small meteor burned up in the atmosphere over the South Pacific, an event so routine it went almost unnoticed. But recently, the United States Space Command made a stunning official confirmation. Based on its incredible velocity and trajectory, that ordinary fireball was in fact the first known interstellar object to ever enter our solar system and collide with Earth. It arrived from deep space at over 130,000 miles per hour, a speed too great for our sun's gravity to hold onto it. This object, a mere 3 feet wide, had been flung from another star and traveled for millions, perhaps billions, of years before its journey ended in a brilliant flash above the ocean. This revelation is profound because it predates Oumuamua by 3 full years. It means our first physical contact with another star system was not a distant observation, but an impact with our own world. The implications are staggering for the sheer abundance of interstellar material. If these objects are common enough to hit our planet, then the galaxy must be teeming with them, a constant, invisible rain of cosmic debris from other solar systems. Most of these visitors are tiny and burn up harmlessly, but their numbers suggest that Oumuamua and the later comet Borisov were not rare flukes, but simply the large, noticeable tip of a vast iceberg. This changes the entire prospect of studying other star systems up close. Instead of building colossal ships to travel for millennia, we could simply wait for pieces of other worlds to come to us. Scientists are already drawing up plans for an ambitious interstellar meteor hunt. The idea is to send a spacecraft to the impact zone of a future interstellar object to sift through the ocean sediment and recover its fragments. Imagine holding a piece of a planet that formed around a distant sun, analyzing its composition to learn about the geology and chemistry of a world light years away. This discovery turns our planet into a collecting plate for the galaxy, offering us a tangible and utterly free sample return mission from the cosmos. While that interstellar meteor was a tiny grain of sand, our solar system is now preparing for the arrival of a true mountain. Astronomers have spotted comet Bernardinelli-Bernstein, a behemoth from the deepest freeze, journeying inward from the Oort cloud. This is not just another comet, it is a mega-comet, a leviathan of ice and rock whose core is estimated to be over 60 miles wide. That makes it about 1,000 times more massive than a typical comet and larger than any we have observed in modern history. Its current path will bring it to its closest point to the Sun in the year 2031, a date that marks a rare and precious opportunity for science. This object is a time capsule. It has spent the last several million years in the Oort cloud, a vast spherical shell of icy bodies that surrounds our solar system like a distant deep freeze vault. Out there, in the profound cold and darkness far beyond the orbit of Pluto, it has remained virtually untouched since the dawn of our planetary system. Its composition is a pristine sample of the original building blocks from which the giant planets like Jupiter and Saturn formed. As it approaches the Sun and begins to warm, its surface ices will sublimate, transforming directly from solid to gas, and in doing so, it will release a cloud of ancient dust and gas that has been locked away for over 4.5 billion years. By analyzing the chemistry of this developing coma and tail, we will be reading the recipe of the early solar system. We can learn what raw materials were available before planets coalesced and understand the conditions that led to worlds like our own. Its immense size also means it will remain active for a very long time, giving us a sustained view of a primordial object awakening from its long slumber. While its closest approach will still be beyond the orbit of Saturn, posing no threat to Earth, its passage is a generational event. We are about to get our clearest look yet at one of the solar system's first and most fundamental ingredients, a frozen giant returning from the void to tell us its story. That ancient recipe for life on Mars may not be a relic of the past at all. The red planet is hiding vast, persistent bodies of liquid water today. The first clues came not from deep underground, but from the sun-baked surface. Orbiting spacecraft have photographed mysterious dark streaks that appear on steep crater walls during the warmer Martian months. These are the recurring slope lineae, and they behave exactly like seeping water. They flow downhill, branch out like river deltas, then fade away when temperatures drop, only to return the following year. The leading explanation is that these are briny flows. Water, saturated with toxic salts like perchlorates, lowers its freezing point dramatically, allowing it to remain liquid in the frigid Martian cold. This brine would ooze from the ground, trickling down slopes just long enough to darken the soil before evaporating or refreezing. But the truly monumental discovery lies far deeper. Using ground-penetrating radar, scientists have detected what appears to be a massive lake of liquid water buried nearly a mile beneath the southern polar ice cap. This is not a small pocket, but a body of water spanning 12 miles across, a subglacial lake eerily similar to those found beneath the ice sheets of Antarctica and Greenland. How can liquid water exist so deep under an ice cap? The answer is a combination of pressure and chemistry. The immense weight of the overlying ice creates colossal pressure, which suppresses the freezing point of water. Furthermore, the water is likely a super salty brine, just like the suspected flows on the surface, allowing it to remain liquid even at temperatures far below zero. This changes the entire search for life on Mars. We are no longer just looking for fossils. We are now considering the possibility of a current living biosphere. On Earth, such subglacial lakes are teeming with microbial life, organisms that have been isolated for millions of years, surviving on chemical energy from the rocks below. If life ever gained a foothold on Mars in its wet past, these deep, dark, watery refuges are where it would have retreated to survive. A subsurface aquifer could provide a stable environment, shielded from the harsh radiation and temperature extremes on the surface, potentially for billions of years. The question is no longer whether Mars was habitable, but whether it is inhabited right now, its secrets swimming in the darkness beneath the ice. Our cosmic timeline is facing a profound challenge from a star that simply seems too old to exist. Astronomers have identified a celestial elder known as HD 140283, nicknamed the Methuselah star, a relic from the dawn of time. Its estimated age, based on meticulous observations of its composition and brightness, is a staggering 14.5 billion years. This presents an impossible paradox because our most precise calculations for the age of the entire universe place the Big Bang at just 13.8 billion years ago. How can a star be older than the cosmos that birthed it? The answer lies not in a broken universe, but in the intricate and uncertain art of cosmic measurement. Pinpointing a star's age is not like reading a birth certificate. For ancient metal-poor stars like Methuselah, which formed before many heavy elements existed, astronomers rely on models of stellar evolution. They measure the star's intrinsic brightness, its temperature, and most crucially, its abundance of elements like oxygen and iron. These measurements feed into complex calculations that reveal how long the star has been burning its nuclear fuel. Each of these measurements carries a tiny margin of error, and when compounded, they create a window of uncertainty. The age of 14.5 billion years is at the very upper limit of that window. When all the uncertainties are properly factored in, the star's true age likely falls just within the universe's lifespan at around 13.4 billion years. This cosmic conundrum has been a powerful driver for refining our models. It forced scientists to re-examine the opacities they use in their stellar models, the precise rates at which light interacts with matter inside a star. A tiny adjustment in this opacity can significantly change the calculated age. It also provides a stringent test for our cosmological models, confirming that the universe is indeed very old, but that our understanding of its very first stars is still a work in progress. The Methuselah star is not an error in the cosmos, it is a precision instrument. Its apparent paradox has sharpened our tools and tightened our numbers, proving that even a seeming impossibility can guide us toward a deeper, more accurate truth. Our own galaxy's motion through the cosmos is part of a much larger and more mysterious river. Astronomers have detected a phenomenon so strange they call it the dark flow, a coordinated drift of entire galaxy clusters rushing toward a single point on the edge of everything we can see. This is not the gentle expansion of the universe, which carries all galaxies apart from one another, but a subtle, persistent current superimposed upon it. Picture thousands of the largest structures in the universe, each containing thousands of galaxies, all slowly but surely being pulled in the same direction. The force required to move such an immense amount of mass is almost beyond calculation, and the source of this pull is completely invisible. It cannot be explained by any known concentration of matter within our observable universe. The great attractors and superclusters we have mapped are powerful, but their gravity is not nearly sufficient to account for this coordinated motion. This leads to a mind-bending possibility, one that stretches the very definition of reality. The dark flow might be the gravitational influence of something beyond our cosmic horizon, from a region of space-time whose light has not had time to reach us since the Big Bang. We are seeing the shadow of a structure so colossal it exists outside our observable bubble, a neighboring super-universe whose immense gravity is tugging on our entire local cosmos. Another, even more radical theory suggests that this flow is a remnant from the very birth of our universe, a cosmic imprint left from the violent period of inflation, a time when the fabric of reality was stretched far beyond its current limits. The dark flow remains a fiercely contested observation, but if it is real, it forces us to confront a humbling truth. The universe we can see with our most powerful telescopes may only be a single island in a far vaster and more mysterious archipelago of realities. The hunt for alien worlds has now reached a new frontier, looking for moons orbiting planets in other solar systems. Around a gas giant named Kepler 1625b, located 8,000 light-years away, astronomers found a tantalizing hint of the first known exomoon. The method of discovery was a masterclass in precision, relying on the subtle shadows cast during a planetary transit. As the giant planet passed in front of its host star, it caused a predictable periodic dimming. But the data held extra clues. A second, much smaller dip in starlight was seen, both just before the main planetary transit and again just after it. This is the signature of a moon trailing and leading its planet, like a small shadow following a large one. The evidence suggested a moon of staggering proportions, a world roughly the size of the planet Neptune. This candidate, designated Kepler 1625bi, would be unlike any moon in our own solar system, a colossal companion to a planet several times the mass of Jupiter. Confirming an exomoon is incredibly difficult because these secondary signals are incredibly faint and can be mimicked by other astrophysical phenomena, such as star spots or the gravitational tug of a second, unseen planet in the system. The initial observations from the Kepler Space Telescope were so intriguing that astronomers secured time on the Hubble Space Telescope for a follow-up study. Hubble watched for a second longer transit, and its data revealed additional anomalies that strengthened the Moon hypothesis. The planet itself began its transit over an hour earlier than predicted, a timing variation that is consistent with the gravitational wobble caused by a massive moon tugging on its host world. Finding such a large moon fundamentally expands our concept of habitable real estate. We typically define a star's habitable zone as the region where a planet could have liquid water. But a gas giant planet itself may not be life-friendly. A massive, rocky moon orbiting that gas giant, however, could have a solid surface, a stable atmosphere, and the potential for oceans. In a distant system, a Neptune-sized exomoon with its own internal heat and a protective magnetic field could be a water world teeming with life, all while orbiting a planet that circles its sun. The search for Kepler 1625b, whether it is ultimately confirmed or not, has opened a new chapter. It proves we can now look not just for planets, but for their accompanying moons, each one a potential island of life in the vast ocean of space. From the silent depths of the cosmos, a single ghost arrived with an address. Scientists detected a high-energy neutrino, an almost massless particle often called a ghost particle for its ability to pass through entire planets without a trace. This particular neutrino had traveled for 4 billion years, and when it finally struck a sensor deep within the ice of the South Pole, it set off a chain of discovery that would mark a new era in astronomy. For the first time ever, researchers were able to trace the path of this elusive particle back to its violent birthplace. The source was a blazar, a monster lurking at the heart of a distant galaxy. A blazar is a supermassive black hole, much like the one at the center of our own Milky Way, but with a terrifying and unique orientation. It is actively feeding on surrounding matter, and we are staring directly down the barrel of one of its relativistic jets. Imagine a cosmic blowtorch, a beam of radiation and particles accelerated to nearly the speed of light, pointed right at Earth. This is the engine that launched the neutrino. The detection was a monumental achievement because it confirmed something physicists had long suspected but could never prove. These ghostly neutrinos are born in the most extreme particle accelerators in the universe. The intense magnetic fields and shock waves within a blazar's jet can crush protons and other particles together, creating a shower of secondary particles, including these hard-to-catch neutrinos. This single event united two previously separate fields of science: particle physicists who study the smallest building blocks of reality, and astronomers who study the largest structures now had a common source. We are no longer just seeing the universe, we are feeling it. We have opened a new window on the cosmos, one that uses particles instead of light to reveal the secrets of the most powerful and destructive objects in existence. The outer darkness of our solar system holds a gravitational secret. Far beyond the orbit of Neptune, in the frigid expanse known as the Kuiper Belt, a population of small, icy worlds is behaving strangely. Their orbits are not scattered randomly as we would expect. Instead, they are clustered together, their elongated paths all pointing in roughly the same direction and tilted at a similar angle to the plane of the solar system. This peculiar alignment is the primary clue leading astronomers to propose the existence of a massive, unseen world, a hypothetical giant we call Planet 9. For these distant objects to be herded into such a configuration, something with immense gravity must be shepherding them. The mathematics are compelling. The only explanation that fits the data is the presence of a planet with a mass roughly 5 to 10 times that of Earth, tracing a vast elliptical orbit that takes it hundreds of times farther from the Sun than we are. This would be a true super-Earth, an ice giant in a class of its own, taking perhaps 10,000 to 20,000 years to complete a single, lonely journey around the Sun. The hunt for this ghost world is now one of astronomy's greatest detective stories. Teams are using the most powerful telescopes on Earth, like the Subaru telescope in Hawaii, to scan the predicted swath of sky where Planet 9 might be lurking. The challenge is staggering. At such immense distances, it would reflect very little sunlight, making it incredibly faint. It moves so slowly against the background of stars that detecting its subtle motion is like trying to spot a glacier shifting from 1,000 miles away. Yet the search continues because the stakes are so high. Finding Planet 9 would not just be about adding a new planet to our textbooks. Its discovery would rewrite the history of our own cosmic backyard, explaining how the outer solar system settled into its current architecture. Its very existence would suggest that our solar system's family is larger and more dynamic than we ever dreamed, with a hidden giant still waiting to be found in the perpetual twilight at the edge of everything we know. Earth itself is not alone on its annual journey around the Sun. A companion travels with us, hidden in plain sight within a gravitational sweet spot known as a Lagrange point. Astronomers confirmed the existence of Earth's second known Trojan asteroid, designated 2020 XL5. This small world does not orbit our planet like the Moon. Instead, it shares Earth's orbit around the Sun, forever leading our planet at a stable point about 60 degrees ahead of us. These Lagrange points are cosmic parking spots where the gravitational pulls of the Sun and Earth perfectly balance with the orbital motion of a smaller object, creating a pocket of stability. Anything placed there tends to stay there, locked in a delicate gravitational dance. The discovery of 2020 XL5 reveals that these points are not just theoretical, they are occupied. This particular Trojan is likely a carbon-rich C-type asteroid, over half a mile wide, and it has probably been our orbital companion for hundreds of thousands of years. Its existence opens up extraordinary possibilities for the future of space exploration. These stable, co-orbital asteroids could serve as ideal way stations for deeper missions into the solar system. Imagine a future space station or a fuel depot constructed on such an object, requiring minimal energy to remain in position. They could become invaluable sources of raw materials, providing water ice for life support and rocket fuel, or metals for construction, all from a location that is energetically cheap to reach from Earth. Our planet's Trojan is more than a celestial curiosity. It is a stepping stone, a natural resource, and a permanent piece of cosmic real estate that has been traveling with us all along. This discovery pushes the very limits of our cosmic timeline, billions of light years away, and therefore billions of years in the past. Astronomers have found a galaxy that was already dead when the universe was in its vibrant youth. Designated ZFCOS 8157, this colossal collection of stars had already shut down, ceasing its star formation when the cosmos was only about 1.7 billion years old. For a galaxy of its immense size to have lived its entire life and died so quickly defies everything we thought we knew about galactic evolution. Our standard models paint a slower, more graceful picture, where large galaxies grow over vast eons by merging with smaller ones, steadily converting their vast reservoirs of gas into new stars across billions of years. This galaxy, however, tells a story of frantic, explosive growth followed by a sudden and violent end. It must have formed stars at a ferocious, almost unsustainable rate, hundreds of times faster than our own Milky Way does today, blazing with the light of countless newborn suns. Then something catastrophic happened to quench it. What force is powerful enough to strangle a galaxy so completely? One leading theory points to the supermassive black hole at its heart. As the galaxy feasted on gas, so too did its central monster. In its final, ravenous phase, the black hole could have become so energized that it blasted out tremendous jets of radiation and powerful winds, effectively sterilizing the entire galaxy. These outflows would have heated the surrounding gas to such extreme temperatures that it could no longer collapse to form new stars, or they could have physically expelled the galactic fuel supply entirely. blowing it off into the emptiness of intergalactic space. Another possibility is that the galaxy's own prolific star formation was its undoing. Countless supernova explosions from its short-lived, massive stars could have combined their force to create a similar galactic-scale wind, clearing out the very material needed to make the next generation. This dead galaxy is a fossil, a preserved relic from an era of cosmic chaos. Its existence proves that the early universe was a far more volatile and dramatic place than we ever suspected, where galaxies could rise and fall with breathtaking speed, their life cycles dictated by the most extreme and energetic physics imaginable. The very fabric of our cosmos is caught in a fundamental disagreement. As we measure the universe's expansion rate, a troubling split has emerged. One method looks back to the dawn of time, using the afterglow of the Big Bang itself, the cosmic microwave background, as a pristine snapshot. This ancient light tells us how fast the universe was stretching in its infancy. Another method uses modern cosmic landmarks like pulsating stars and exploding supernova in our galactic neighborhood to measure the expansion rate today. Both techniques are incredibly sophisticated, yet they yield two different answers. The universe now appears to be expanding faster than the early universe data predicts it should be. This growing chasm is known as the Hubble tension. It is not a small statistical fluke, but a persistent gap that has only widened with more precise measurements. This discrepancy suggests that something is missing from our standard model of cosmology. Perhaps dark energy, the mysterious force driving the acceleration, is not a constant after all. What if its strength has been changing over billions of years, growing more powerful and pushing galaxies apart with increasing vigor? Another possibility involves exotic new particles or a flaw in our understanding of gravity itself on the largest scales. The Hubble tension is more than a technical problem for astronomers. It is a potential crack in the foundation of modern physics. If our most basic measurement of the cosmos is in conflict, it means our story of the universe is incomplete. This crisis of expansion forces us to question everything we thought we knew about the fundamental forces that have shaped reality from its first moment to the present day. Deep within a dense stellar corpse, the laws of physics are being rewritten. Astronomers have found a pulsar that spins with such ferocious speed it threatens to tear apart our fundamental understanding of matter itself. This is not just a fast-spinning star, it is a cosmic outlier, a beacon whose very existence defies the established rules governing the most extreme objects in the universe. A pulsar is the crushed core of a giant star that went supernova, a neutron star so dense that a single teaspoon of its material would weigh billions of tons on Earth. As it spins, it beams radiation from its magnetic poles, and if that beam sweeps across Earth, we see a regular pulse of light like a cosmic lighthouse. This particular pulsar, however, is spinning hundreds of times every single second. At that rate, the surface at its equator is moving at a significant fraction of the speed of light. The centrifugal force generated by such a dizzying spin should be powerful enough to rip the entire star apart, flinging its ultra-dense material out into space. Yet somehow it holds together. This presents a profound challenge to our models of neutron star structure and what physicists call the equation of state for ultra-dense matter. This equation is a theoretical description of how matter behaves under pressures so immense that atoms cease to exist, and protons and electrons are crushed together into a soup of neutrons. We simply do not know what form matter takes at these densities. Is it a superfluid of neutrons, a crystal of exotic particles, or a soup of free quarks? The impossibly fast spin of this pulsar suggests that the internal structure of a neutron star is far stranger and more rigid than we ever calculated. It might be filled with a bizarre state of matter known as strange quark matter, a substance that is fundamentally more stable and resistant to centrifugal force than anything we can create in a lab. Each pulse from this stellar rebel is a direct challenge, a signal that in the heart of these cosmic graves, matter exists in a form beyond our current imagination. The air of an alien world has just whispered its secrets. The James Webb Space Telescope has turned its golden eye toward a distant exoplanet, and in the faint starlight filtering through its atmosphere, it has found a chemical paradox. The data reveals the simultaneous presence of both oxygen and methane, two gases that should destroy each other. On Earth, this volatile combination is a powerful biosignature, a chemical signature that life alone can sustain. Oxygen is highly reactive, constantly seeking to bind with other elements and vanish from the air. Methane is its fuel, and when they meet, they react and disappear. For both to exist in significant quantities in a stable atmosphere, something must be constantly replenishing them. That something on our planet is life. Plants and cyanobacteria pump out oxygen, while microbes in wetlands, the guts of animals, and geological processes release methane. Finding this pair on another world is the moment we have been waiting for, the first tangible hint that we are not alone. But the scientific community will not declare victory with a single reading. The road to confirmation is long and paved with skepticism. The first task is to rule out every possible non-biological or abiotic explanation. Could geological processes like serpentinization, where water reacts with certain rocks, be producing the methane? Could photochemical reactions in the upper atmosphere, driven by intense stellar radiation, be splitting water vapor to create a trickle of oxygen? Astronomers will point every available instrument at this world, studying its host star for activity that might mimic these signals, modeling its climate to see if natural processes could maintain this chemical imbalance. They will watch for seasonal variations in the gases, a pattern that would strongly suggest a living world breathing in and out. They will search for other corroborating evidence, like a glow in the atmosphere from vegetation, or the presence of industrial pollutants that would point to a technological civilization. This discovery would not be an end, but a magnificent beginning. It would ignite a global effort to build even more powerful telescopes designed for one purpose, to stare at this one point of light and finally answer the ancient question. Are we the universe's sole children, or have we just heard the first faint breath of a neighbor? The very gold in a wedding ring or the platinum in a catalytic converter was born in a cataclysm of almost unimaginable violence. For decades, the origin of the universe's heaviest elements was one of astrophysics' greatest unsolved puzzles. We knew that regular stars forged elements like carbon and oxygen in their cores, and that supernova created many others. But the elements heavier than iron, those in the bottom half of the periodic table, required something more. They needed a frantic rush of neutrons, a process where atomic nuclei were bombarded so intensely and so quickly that they could not decay, gluing on more and more neutrons to build heavier and heavier atoms. The question was, where in the universe did this extreme environment exist? The answer arrived in a single, spectacular event in August 2017. Gravitational wave observatories detected the ripples in spacetime from a colossal collision happening 130 million light-years away. For the first time, telescopes around the world and in space were alerted and swiveled to look. What they witnessed was a kilonova, the explosive aftermath of two neutron stars merging. The initial collision was brighter than a billion suns, but the real magic happened in the expanding debris. The intense neutron-rich material ejected from the wreckage provided the perfect cosmic crucible. In this maelstrom, the rapid neutron capture process, or the R process, ran wild. Common elements were transformed into rare, heavy treasures. In just a matter of days, this single event produced an astonishing amount of cosmic wealth, forging gold and platinum with a combined mass perhaps hundreds of times greater than the entire Earth. This observation was the definitive proof. the universe's precious metals, the very elements that make up our most cherished objects and advanced technologies, are not made in the calm furnaces of stars, but in the chaotic, violent mergers of stellar corpses. Every piece of gold is ultimately stardust, but a specific kind, forged in the final, spectacular death spiral of two ultra-dense stars. This discovery connects us directly to the most energetic events in the cosmos, revealing that the history of everything, including the atoms that make up our bodies and our world, is written in the echoes of ancient collisions. This cosmic alchemy of gold and platinum hints at the universe's profound capacity for creation through destruction. But what if the process could be reversed? The hypothetical white hole represents the ultimate act of cosmic defiance, a theoretical region of space-time where matter and energy can only pour outward, a one-way exit from the universe that is the exact opposite of a black hole's relentless pull. While black holes are defined by their event horizon, a point of no return from which not even light can escape, a white hole would possess its own impassable boundary, a surface that forbids any entry from the outside. Nothing from our universe could ever cross in, only emerge from it. This idea arises naturally from the complex mathematics of general relativity, where solutions to Einstein's field equations can describe these exotic objects as a kind of time-reversed black hole. For decades, white holes were considered little more than a mathematical curiosity, a theoretical possibility with no basis in physical reality. But recent speculative models have begun to bring this idea back into the conversation, suggesting they could be more than just a phantom in the equations. One provocative interpretation considers the possibility that a black hole, at the very end of its life through a process of quantum evaporation, might not simply vanish, but could instead undergo a dramatic transformation into its white hole counterpart. Another line of thought ponders whether the Big Bang itself could be viewed as a primordial white hole event, a single, colossal eruption of space-time and energy that gave birth to our entire cosmos. While no observational evidence for a white hole currently exists, their potential existence forces us to confront deep questions about the nature of time, causality, and the ultimate fate of reality. Could the universe be dotted with these cosmic fountains, endlessly pouring new material into the void? The search for them now involves looking for unexplained, high-energy outbursts in space that lack any clear source, events that might just be the signature of a white hole briefly opening. This is the frontier where established physics meets profound speculation, a reminder that our universe may still hold the greatest surprises of all. A silent storm is passing through our cosmic neighborhood right now. This is not a tempest of wind and rain, but a hurricane of stars, a vast stream known as S1, the shredded remains of a dwarf galaxy our own Milky Way cannibalized billions of years ago. This river of suns is moving at a staggering 1 million miles per hour, slicing directly through the region of space our solar system currently occupies. And according to our best models, this stellar stream is not traveling alone. It is believed to be dragging an immense concentration of dark matter along with it, a direct, high-speed gust from this invisible hurricane. For the first time, we are not just looking for dark matter in the abstract, we are sitting directly in the path of one of its most powerful currents. Dark matter is the universe's greatest ghost. It does not emit, absorb, or reflect light, making it completely invisible to our telescopes. We only know it exists because of its gravitational pull, the way its immense but unseen mass bends the paths of light from distant galaxies and dictates the rotation speeds of stars within them. It makes up about 85% of all the matter in the cosmos, yet we have never directly identified a single particle of it. All our attempts to catch it in ultrasensitive detectors buried deep underground have so far come up empty. The S1 stream offers a completely new approach. Think of it like this. If you were trying to study an invisible wind, you could wait for a calm day and hope to feel the faintest breeze. Or you could stand in the path of a hurricane where the force is so strong it cannot be ignored. This stellar stream is our hurricane. The dense clump of dark matter moving with it should significantly increase the number of particles passing through our detectors every second. Experiments like LUX Zeppelin, located in a former gold mine a mile beneath South Dakota, are now on high alert, their tanks of ultra-pure liquid xenon waiting for the telltale flash of light and charge that would signal a dark matter particle bumping into a xenon atom. The nature of that signal, if we see it, would tell us everything. It would reveal the mass of the particle and how it interacts with normal matter, finally giving this cosmic ghost a face. We are living through a unique and fleeting astronomical event. This dark matter hurricane will not last forever. In a few million years, the S1 stream and its invisible cargo will have moved on, leaving our region of the galaxy. For this brief window, however, we have a front row seat to one of the universe's most profound mysteries, a chance to reach out and finally touch the shadow that shapes the cosmos. From rogue planets adrift in the dark to the violent forges of cosmic gold, our journey through these 30 discoveries reveals a universe far stranger and more wonderful than we ever dreamed. Each finding, whether a gas in the clouds of Venus or the steady heartbeat of a distant radio burst, is more than just a new fact, it is a key turning a lock. These revelations are actively dismantling old assumptions, challenging the very foundations of physics, and redrawing the map of what is possible. They prove that the cosmos is not a static museum but a living, breathing, and often violent arena of continuous creation and mystery. The frontier of knowledge is not receding, it is exploding outward in every direction, inviting us to look deeper and question everything. Our place in this grand story is not as passive observers, but as active participants in a great age of discovery. So the next time you find yourself under a clear night sky, remember the hidden oceans on distant moons, the invisible giants shaping our galaxy, and the silent, ghostly particles raining down upon us. Let that sense of wonder pull your gaze upward. The universe is speaking to us in a language of light, gravity, and chemistry, and we are only just beginning to learn how to listen. We want to know which of these discoveries reshaped your understanding of reality. Tell us in the comments which one leaves you utterly astounded.